Okay, so we're going to look at section 4.4 now, and so this is on injectivity, surjectivity, and bijectivity. Okay, so we're going to start out with just an arbitrary function that maps A to B. Okay, so the map F, so remember mapping function, those can be used interchangeably. So the map F, this is injective. Okay, so this is the definition of injective. If whenever x does not equal y implies that f of x does not equal f of y. Okay, so another name that you might hear for injective, maybe you've heard in the past, is one-to-one. So if you're looking at a one-to-one function, a one-to-one function has this property. So as long as you have two different numbers, then their function values must be different. Now, equivalently, if f of x equals f of y, then x is equal to y. So the question is, why is that an equivalent statement? Well, this statement is what to this guy? Contrapositive, exactly. So this is the contrapositive. So the contrapositive of this statement is the following. So if there's two function values that are the same, that means it must come from the same number. Okay, so if you think about one-to-one functions, these are the more common ones that you've seen in the past. These are going to be ones that pass the horizontal line test. So remember, the vertical line test in functions says that for every input, there's only one output that corresponds to it. You can't have two different outputs. So vertical line can't pass their function twice. Now, a one-to-one function instead looks at the horizontal line test. So that says that for every output, so if you look at different outputs, you can only have one input that maps to that output. And so that's what they're saying here, that if you have two different numbers, the function values of those numbers must be different. So you can't have two numbers with the same function value. Okay, that is injective. The next one is surjective, or other words you might, if you take in modern algebra, sometimes people will use onto as another way to describe that. Okay, so surjective or onto, that says that for every element in B, so remember B is our codomain, so for every element in the codomain, there exists an element in the domain, so there exists an A and A, such that f of A is equal to B. So what this is stating is that every element in our codomain has something from the domain that is mapping to that function. Okay, or mapping to the element. All right, then the last definition here is bijective. So bi prefix meaning two, it has these two properties to it. It is both injective as well as surjective. So we have injective, different elements are going to be mapped to different function values. We have surjective, every element in the codomain has something in the domain that maps to it, and bijective means that it is both injective and surjective. So I'd like to take a look at some examples over here. So we have these four different functions that I've defined. So I've just defined mappings from A to B. So you can see all of these. If you want to try this before I give away the answers, feel free to pause the video and look at these and figure out which ones of these are injective, which ones of these are surjective, and which ones of these are bijective. So feel free to pause the video, give it a try. So if we look at this first one over here, we see every element in the domain gets back to something in the codomain, so this is at least a function, right? All four of these are functions, so you don't have to worry about any trick questions taking place here. So for injective, that says that if we have two different numbers or two different elements in here, they must be mapped to different things into our codomain. But because we have two different values here that have the same function value, this is not injective. So this is not an injective function. Is this surjective? Well, yes, indeed, because surjective says every element in the codomain has a buddy mapping to it. So this is something that is surjective. Is this bijective? Well, no, because it's not injective, so not bijective. This one over here, we look at this one, we take every element over here. Does it get mapped to different elements there? So no. So this is an example where it is not injective again. Surjective, is this surjective? Well, does every element in the codomain have a buddy mapping to it? Well, no. So this is not surjective. Here, if we have, does every different element in the domain get mapped to a different thing in the codomain? Well, yes. So this is injective. Is this surjective? Well, no. Obviously, this element does not have a buddy mapping to it, so this is not surjective. This one here, we see that because every element, different elements here get mapped to different function values, this is going to be injective. Every element of the codomain has a buddy mapping to it from the domain, so this is surjective. So what this says about this function is that this is a bijective function. So those are those three definitions we want to become comfortable with. Seeing them hopefully through just these basic sets is nice and easy. We're going to take a look at how do we deal with more functions that deal with x's and domains and codomains that are larger than just a discrete small set like this.